Last year at the ElCon 2025 conference, I presented one of the two research areas that interested me there, and my study was gait cycle detection in patients with lower limb prostheses. This year, I will present the second topic, which is no less interesting to me, sports rehabilitation, and my topic is bilateral asymmetry of the knee extensors in healthy athletes during squats, an OpenSim and motion capture study. Bilateral differences in knee extensor function, particularly during exercises like squats, may lead to compensatory movement patterns that alter load distribution and increase injury risk. Usually, coaches give instructions verbally without drawing conclusions from real data on the dynamics of the athlete's muscles. I developed custom computational methods enable extraction of muscle-specific biomechanical parameters that are not available through standard motion analysis software. This program calculates and visualizes statistical data of muscle tendon rectus femoris elongation in dynamics during a cycle of exercises. On the first picture, you can see the exact muscle I studied in the athletes, the rectus femoris. On the second picture, it shows how asymmetry during exercise over the long term can lead to problems in knee, ankle, hip joints, and even posture issues. I work as biomechanical engineer at the Federal Scientific and Educational Center of Medical and Social Expertise and Rehabilitation named after Albrecht, and our motion capture lab usually equipped with a set of high-speed infrared cameras, a set of passive markers, 2 or 4 force plates, and electromyography sensors. In this study, a motion capture system and passive markers will be used. This slide presents the characteristics of the study participants. There were 5 participants and their age, height and weight are listed here. Squats are a fundamental multi-joint exercise that primarily targets the lower body's kinetic chain, and analyzing the function of main muscles like rectus femoris, especially through the lens of bilateral asymmetry, provides direct insight into an athlete's movement efficacy and potential injury risk. The objectives are to conduct motion capture analysis of 5 athletes, develop personalized OpenSim musculoskeletal models, implement custom Python algorithms for quantifying 7 asymmetry parameters, including peak elongation differences, amplitude variations, and temporal delays. In Figure 9, you can see an athlete performing the exercises wearing passive reflective markers. Figure 10 shows the individually built skeletal model of the athlete. Finally, Figure 11 presents the musculoskeletal model with muscles scaled according to the athlete's individual parameters, created in OpenSim, a software platform for musculoskeletal modeling and simulation. For data processing and visualization, I used several Python libraries, NumPy, SciPy, Pandas, as well as my own algorithm, currently undergoing registration as computer software. The analysis was performed on 5 athletes. This slide currently displayed the results for 1 athlete. Here we present muscle tendon length differences during the squat cycle with a sign. Areas where the right muscle is longer are marked in blue. Areas where the left is longer are in pink. Below, that is the graph of the absolute differences in centimeters. Further below is the graph showing the rectus femoris length change over time, highlighting the movement of maximum differences during simultaneous stretching. The right limb is shown in blue, the left in red. Also, slide 7 featured the differences presented in an alternative format along with the maximum differences recorded for each peak during the exercise cycle, 12 peaks in total. Slide 8 presents the statistical analysis of muscle tendon parameters for the athletes, including 7 asymmetry metrics, one of which is the phase delay at peak. Essentially, 4 athletes showed a difference of less than 50 millimeters. However, one athlete exhibited a difference of exactly 50 millimeters. This serves as a red flag indicating potential issues such as incorrect exercise technique, established improper muscle recruitment patterns, or the activation of compensatory mechanisms. This particular case is valuable for future in-depth analysis. My project was recently featured in Russia's most cited media site, and a news story about it was also filmed for St. Petersburg's main city television channel. In conclusion, I developed a specialized software pipeline and used it to quantify key asymmetry parameters in the rectus femoris muscle during squats. The next steps are to apply this method to larger groups, different exercises, and link the findings to real-world athletic performance and injury risks. Thank you. If you have any questions, you can ask me.